Okay, just going to go through another request from exercise 10E, page 172, which is question 7. We're talking about two particles A and B, one of mass 6 kilograms, the other one unknown mass, connected by a light inextensible string. B is below A, and a force of 118 newtons is applied vertically upwards, causing the particles to accelerate upwards. Now, we're asked to find out the mass of the particle and the tension in the string. And there's many ways to do this. I'm going to show you the way I would do it, which is treating these particles separately. So I'm going to resolve object A only. Just object A. Force is acted on object A. Well, we've got that 118 newtons. We've got its weight, 6g newtons. And we've also got it's attached to a string. So this string is going to be trying to pull it back down. So the tension is going to be pointing downwards. And those are the only forces acting on object A. It's accelerating, so F equals ma. The mass of the object is 6 kilograms. The acceleration of the object is 2. Forces going with the motion is 118. Subtract the forces going against it, which is T and 6G. If you make T the subject, you get 118, subtract 6 9.8s, subtract 6 2s, which is 47.2 newtons. So I've actually worked out, but it looks a bit part B first, which doesn't really matter. So part A is going to be resolving B only. So just thinking about the forces acting on B. B has a weight, mg. And B is attached to a string again, and that string is going to try and pull B upwards. So tension would be going upwards from the perspective of B. It's accelerating still, so F equals ma. The mass of object B is m, the acceleration of object B is 2, and the resultant force would be forces going with the motion, subtract the forces going against the motion, and then you've got an equation with two unknowns, but you know what T is. It's the same as above. That's one of the assumptions. Minus mg equals 2m. Make m the subject. You can factorize out m. Actually, what you could do is write 2m plus 9.8m. So 47.2 is equal to 11.8m. And the mass is equal to 47.2 divided by 11.8, which is 4 kilograms. And that's how you could do this one.